Okay, for example 3, a model train consists an engine, okay, locomotive coupled to a chain of 4 trucks. The coupling between the engine and the first truck and each coupling between the trucks are modeled as rigid rows. The train is moving on a straight horizontal track. The engine has a mass 0.8 kg and each truck has a mass 0.2 kg when empty. The resistance to the motion is 0.06 on the engine and 0.01 on each truck. The driving force produced by the engine is 3 Newton. Okay. A mass of 0.1 kg is placed for each truck. Find the tension in each coupling. Okay, so for this question, right, if you want to find the A by solving the simultaneous equation for individual item component, so will be very complicated. So for this kind of multi-coupling system, same things, we will consider the total system first, right? Then find the A, and then you find the T by individual item. Okay, so now we consider this is a total system first. So if this is a total system, you have a big one. Okay, the driving force 3 Newton. Okay, you have a resistance of 0.06 for the engine and 0.01, okay, for the trucks. Okay, so now so here you have a 0.01, okay, times 1 2 3 4, okay, and another one will be 0.06, okay, and the total weight of the full system will be 0.8 for the prime mover, is it? Okay, for the engine, and 0.1 0.1 0.1 for the extra weight that you have put on the item, and 0.2 for each item. So you may form a net force equation 3 minus 0.06, okay, minus 0.04 plus 0.04 is equal to 0.8 plus 0.4 and plus 0.8 also, and A. Okay, so because 0.2 you have four trucks, right? Okay, so you have a net force equation in this way. Okay, by continue calculation, you will have 3 minus 0.1 is equal to 2A. So A is equal to 1.45. Okay, 1.45 meter per second square. Right. So now you have the A already. Okay, so in order to find the tension for each coupling, okay, find the tension for each coupling, okay, you need to form individual net force equation for each component. Okay, so we try to draw the diagram first. So the first item you have, sorry, the last one you have T. The last one you have, let us know last one. Use the first one first. Okay, the first one, we have three here. Okay, and the engine side. So here you have 0.06, and we assume this is a tension T1. Okay, and we can form a net force equation 3 minus 0.06 minus T1 is equal to 0.8 A. Okay, for the engine side. So by sub the A inside, you should get T1, the coupling for the between the engine and the first truck will be 1.78 Newton. Okay, for the first, between the first truck and the engine. Okay, so by do the similar way for the second, between the second, for the first truck and the second truck. Okay, so I draw the trucks. Okay, so you have a T1 here and T2 here. Okay, T2 is between the first truck and the second truck. Okay, and you have a, don't forget you have a 0.01. Okay, so you can have equation T1 minus 0.01 minus T2. Total mass will be 0.1 plus 0.2, 0.3A. Okay, so by solving this, just now you have a T1 already. By solving this, you should get T2 for the second coupling is equal to 1.335 Newton. Okay, we can write it maybe 1.33 Newton, right? Okay, by doing a similar way, we proceed to the third coupling. Okay, for the third one, you take the second trucks. So here is T2, T3, 0.01. Okay, so same things, T2 minus 0.01 minus T3 is equal to 0.3A. Right. So by solving this, by sub the A inside and sub the T2 inside, you should get T3 is equal to about 89 Newton. Okay, T3. Okay, so for the last one, here is T3. Okay, here is T4, here is 0.01. Alright, so you have T3 minus 0.01 T4, okay, is equal to 0.3A. Okay, so by solving this, you will get T4 is equal to 0.445 Newton. Okay, so the forces in the each coupling, right? So for part A, okay, for part B, find the tension in each coupling is still, if instill that 0.4 kg is all placed in the last truck. Okay, so for this part B, the driving, if you consider total system, the full system, okay, the driving force is the same. Okay, and don't forget the total resistance still the same. Okay, the total mass is still the same, right? So you have the acceleration ascent also. Okay, you have the same acceleration also, but because the weight already put on the last coupling, okay, you may have different values in each coupling. Okay, let us see what happened. Okay, so for the first coupling, okay, for the first coupling, for the first coupling, you can draw the diagram. Okay, same things 3 minus 0.06 minus T1 is equal to 0.8a, right? It's the same. So you by solving this, you will find T1 is equal to 1.78. Okay, so similar to the previous question, previous answer. Okay, T1. Okay, so this is for first coupling, first tension. Okay, how about from the second coupling? We have T1 minus 0.01, okay, the resistance, and minus T2. This time because the weight already at the behind, so you only have 0.2a. So for solving this equation, you have T2 equal to 1.48 Newton. Okay, you can see that, okay, T2 actually increase already. T2 increase. Okay, so for the third coupling, T2 minus 0.01 minus T3 is equal to 0.2a. Okay, so T3 is equal to 1.18 Newton. Okay, so T3 also increased already. Okay, right. Now we go for the fourth coupling. T3 minus 0.01 minus T4 is equal to 0.2 a, right? And so that by solving this, you have a T4 is equal to 0.88 Newton, also increase, right? So this is the effect that you put all the weights on the last trucks, okay? Right, so uh, this is for question 3, okay?